Hello everybody, let's just get the stream up. How is everybody doing tonight? Hope you're all doing great. Hope you guys can hear me as well. Microphone looks good. Okay, cool. So, welcome again to another stream. This is almost kind of a continuation of the last stream because I actually found it interesting what we were doing on the last stream, especially with the BGP peering that we were doing, and we were trying to get VRRP running and spanning a whole network across between some MikroTiks, and I kind of just wanted to start up that lab again. I want to do a few more things, see if we can maybe get things working. I want to implement a few extra things, especially the OSPF and MPLS as well on our routers. And let's see if we can actually make something work. I've got the topology on the screen here. Before I go into that though, there's something I saw that's very interesting to me. I don't know if you guys have heard about it. Let me just bring it on the screen quickly. But I saw a post on one of the MikroTik groups that I belong on Facebook, and these guys are claiming that they can do SD-WAN for MikroTik, which is massive if they can actually achieve this flawlessly. So I am trying to get, I think I've got a discussion with these guys next week, and then if it works really well, I might even make a video about it. But I want to see SD-WAN on MikroTik, but I would really like MikroTik to offer this as a service, because it's always a bit weird if you're going through a third party, because if the third party stuff doesn't work, the MikroTik will just be like, it's a third party thing, we don't really care. So that's why I'm like, let's say, cautious, but I'm optimistic as well that this works. Hang on, why did I close that screen? Let's just close that MikroTik SD-WAN thingy, and let's go back to the topology. Let's talk about redundancy. So I'm just going to start up our routers again. Actually, I'll start up all of the gears and get everything working. I might just turn down my music volume a bit. Otherwise, it feels like I'm having to shout to myself, which is weird because then I'd be shouting to you guys, and then that's no fun. All right, equipment is starting up. So last time what we were trying to achieve was we've got two different sites. One site is in the 10.1.1.0/24 subnet, and the other site is in the 10.1.2.0/24 subnet. And there's these two MikroTiks on the edge, and they both have basically like VRRP configured so that if one of the routers go down, that the other router could just take over the routing or the connectivity aspect of that network. And it's that way for both sides. The issue that we were having last time was we were testing where we basically shut down the primary VRRP router, and the second router was supposed to take over, and it did take over from a VRRP perspective, but the routes for the BGP was kind of getting the word I'm going to use is mangled, even though mangle is very good on MikroTik. It was weird seeing that this MikroTik 3 was essentially trying to route traffic to something that it doesn't know about. And that's what I want to try and fix with a bit of extra OSPF and other route functions. So let's just quickly set those things up. I'll quickly do a few on Winbox, because first thing I want to do is just change how the setup works, because there's these links between all of the routers and I'm connecting directly with these layer 3 IPs for the BGP. I want to change that. I'm going to set up OSPF, and then I'm going to add loopback addresses on each of the routers, kind of like on that first big mega lab I did, and then we'll connect using the loopback addresses to establish BGP peers. So that's one thing we're going to do. The other thing is I might also just add MPLS into the mix, because we want to also just have a way to push these routes properly across the core network. All right, so Winbox, neighbors, let's jump onto R1, which is that MikroTik 1, admin blank. So first things first, we set up the OSPF. So you want to copy basically config files from the command line, is that it? We can have a look at that. I don't often do it that way because it's very quick to just drag and drop into MikroTik. I know it's fairly straightforward from the terminal just to export the config out, but bringing the config in might be something interesting. But we can look at that just now. But let's just first set up this OSPF redundancy. I'm on router 1, so first thing we want to do is we can use the default instance because that's already kind of like the backbone, and we will make this the backbone. So we can change the name maybe to backbone. A router ID I'll make 9991, and I won't touch anything else here, and I'll just apply this. And the next thing I'm going to do is I'm just quickly going to look. We've got an area already. It's called backbone. It's already in the right area, so we don't need to add any areas here. And we're just going to add networks quickly, which will be the links. So that's the 10.100.0.0 and 10.100.2.0. So 10.100.0.0/30. We put that in the backbone. And 10.100.2.0. I should now get some dynamic interfaces, and they are not going to do anything because we don't have OSPF configured on anything else yet. To make this a bit more interesting, because I got asked last time, why don't you make it point to multi-point or point to point? And the answer is simple. It's fine to leave it on broadcast, but if you want to put it on point to multi-point, it's fairly straightforward. We can just copy this interface, and we can just set this to PTMP. That's for point to multi-point, and here we can use stuff like use BFD. I know that one of my viewers actually posted on, I don't know if it was my BFD video, but apparently he was having issues on his BGP with BFD, and I did some research, and it looks like there was, I don't want to say was, maybe there is, maybe there, I don't know, but it seems like OSPF doesn't like BFD a lot. So maybe don't use BFD unless you're very comfortable with it. But it seems more like a problem with bigger networks. And BFD is also kind of a redundancy thing because it's let's say a protocol that we can use that just increases or makes the network convergence a lot quicker. If you use BFD, it turns it into a few seconds or even milliseconds, as opposed to, sometimes having to wait for a hello timer to run out on something like BGP. All right, but let's just put interface or ether1 as point to multi-point. We can okay that. That dynamic interface will just whoosh away. And ether2 will do the same. Point to multi-point, apply that, okay. And there we go. So the OSPF is good on router 1. Let's quickly do the OSPF on router 2. And let's see here. I want to do it on the command line. I want to do 3 and 4 maybe on the command line. So let's jump onto router 2. Go into our instance. Just rename this to backbone. I don't know. You really don't have to, but I like doing that. Areas, that's fine. It's already got that area. It always has that area by default. I don't know why I'm checking. I just like checking to make sure it's there in case. All right, so we're also going to add the 10.100.0.0/30, and that's not good. I don't like that. Hang on. Let's just look at our IP addresses quickly. I don't really like this. Maybe this was a big issue for the redundancy. No, wait, it's not. Never mind. So 10.100.2 is what we want to set up. This is just not set up right. No, but what about this other side? I'm being such an idiot now. I'm looking at the wrong equipment again. Sorry. But I don't like it. It was like this, and that doesn't look good. All right. Let's quickly check here. 10.100.2 and 10.100.1. Okay. That's quite simple enough. So routing, OSPF, networks, 10.100. So it was 2.0/30 and .1. So we can just copy that to make it a bit quicker. Apply that. And then I'm also just quickly going to set the interfaces for point to multipoint. Nothing fancy, this is very quick to set up. I'm a critic different places, no direct link, and I connect to them using public IP, and I have ubiquity antenna going to customers. Oh, that's an actual bummer, actually, having to physically go to make changes. That doesn't sound nice at all. And that's on the ubiquity? Doesn't it have any... I mean, I've set up a few point-to-point links, maybe using like air fiber and whatnot, with ubiquity, and I can most of the times make the changes remotely. But I guess that depends on the version of the equipment and the equipment that you are using. All right. This Ether2, I need to just change to point to multi-point as well. All right. I'm happy with that. Let's quickly jump onto our other routers. So, oh no, I'm not going to connect like that. I'll just connect straight from Eve. Admin blank. IP address print. I just want to make sure what our IPs are. Okay, so that was right. I just put that 3 in the wrong location from the last time we did this. Hey, Tobias. All right, so next thing we want to do is just do routing OSPF. We are first just going to set our instance. I just want to set the name to backbone. Then I want to do routing OSPF network. Let's add the networks, and that will be 10.100.0.0/30 in our backbone area. And we're going to do the same for 10.100.3.0. And then, oh, this is the only crappy part now. If I do a routing OSPF interface and I print that, I'm getting these dynamic interfaces, but you see I don't actually have an interface that I can copy from here. So all that I'm going to have to do is routing OSPF interface add. Interface is Ether1, and I just want to have a look what our network type is going to be. PTMP. All I want to change, and then we're going to do the same for, is it Ether2? Yes. So if I do a routing OSPF print or routing OSPF neighbors print, I can see I've formed adjacency. The state is full, and we can get a nice like full thing if we do print detail. Like this gives a little bit more. Actually, it doesn't give that much more detail in this sense. But for on BGP, it gives a lot more information. All right, so let's just quickly do our last router. And this is so dumb, I actually should have added the loopback addresses, but I kind of forgot. So we can add them just now. Okay, so routing, OSPF, instance, set name, backbone, routing OSPF network add. Hang on, let's just do an IP address print, and then we can do a routing OSPF network add. Our networks are 10.100.10/30 for the area backbone, and 10.100.3.0. And then we just quickly want to add our interfaces. So OSPF interface add. Our interface is Ether1. And the network type will be point to multi-point. And we'll do the same for Ether2. And then technically our OSPF setup is done. So routing OSPF neighbor print. Let's just do an IP route print. So I should be learning a bunch of OSPF routes as well, which I am. All right, that's fantastic. Let's just quickly add those loopback addresses. So I'm just going to do like 9991 9992, 9993, 9994. Let's just duplicate some text and put it under the router so that we can actually see which one is what. Let's just make that a nice red, maybe make that a bit more bold. So router 1 is 9991, router 2 is .2, router 3 is .3, and router 4, or it just says MikroTik, but that should be 4, is .4. All right. So let's just quickly set up these loopback addresses so that we can use them to connect with BGP. I'll quickly, let's just do router 4 quickly since I'm connected here. So interface bridge add name LO0, IP address add address 999.4. And then, hang on, I just need to set that interface. Sorry about that. And then we want to do a routing OSPF network. We want to add a new network for 999.4 into our backbone. Cool. I might leave this PuTTY session open and just switch around between it because it is a bit quicker. What did I do there? There we go. Okay, so router 3, same thing, interface bridge add name LO0, IP address add address 9993, interface LO0, and then routing OSPF network add network is 9993 with the ARIA being backbone. Cool. Let's quickly do the 2 other routers on Winbox. All right, there we go. Let's go into our interfaces, or let's go into bridges. Add a new bridge, call this LO0. Apply this. Add the IP address of 999.1 to LO0. And let's quickly go to our routing OSPF and let's advertise 9991 into the backbone. Awesome. And let's jump onto another Winbox session for router 2. Go into our interfaces or our bridges, sorry, go into bridge, add a new bridge, LO0. Let's add an IP address of 999.2 on LO0. All right, that looks good. Let's jump into OSPF and just advertise this route out. 9992. Apply that. All right. That is very good. So if I look at my IP routes, I should actually be receiving all of my loopback addresses. Let's not look at the VRF. Let's look at our main routing table. Yes, so I can see 9991, 9993, and 9994. Perfect. This is awesome. Okay. Now, I want to actually add MPLS on top of this so that we have that label distribution as well. Hang on, I'm not using any static routes except for the default routes out. The OSPF is essentially just here as an IGP to carry the backbone traffic across because we want to form some BGP peers. And don't worry, you're not late, Tobias. This is, I said it at the start of the video, but this is a continuation of last week's live stream as well, where we set up this type of lab, which another viewer actually was having issues with, where you wanted to have, let's say, 2 sites in the same VRF, and he wanted them to communicate directly with each other, but there should also be some redundancy in the form if one of these routers go down, that the other router takes over. That's why we've got like VRRP set up. So it's a big setup, but none of this should be achieved with any type of static routing. This will all just be the protocol we used was BGP, and we're still going to use BGP to learn those routes. But it was also via IGP. What I didn't like was us setting route reflectors on all of the routers. But think of this more as me trying to figure this out as well. This isn't really like a lesson me being specifically like, hey, this is how BGP works. This is me continuing on the redundancy of what another viewer was having issues with. And I just found it really interesting. I want to see if we can figure this out and make it work. All right, but now we've got OSPF. We're sending loopback addresses across the whole network. So what I want to do next is just set up our MPLS for LDP. So we'll do this very quickly just by doing our MPLS LDP settings, enabling it, setting our LSR IDs, 99991, set that for the transport address as well. And then I need to just add my interfaces quickly. So Ether 1 and Ether 2. I know is going to do the MPLS. All right. Now we can just quickly close that and go into router 2. Actually, I don't even need to close. I can just go to router 2 quickly. We can even put them side by side. Get a nice view. All right, so MPLS. We're going to set the settings to be enabled, but this will now be 9992. Apply that. Add our LDP interfaces, so Ether 1, Ether 2. Hey, Stefan. And I should actually start seeing there is an LDP neighbor. Perfect. All right, let's quickly do the other two routers, so router 3 and router 4. So for this, we're just gonna go MPLS set enable. Hang on. MPLS LDP set enabled, yes. We want to set our transport address. This is router 3, that's 9993. And we want to just set our LSR ID, which will be the same in our case. And we are going to just do MPLS LDP interface add interface equals Ether 1 and Ether 2. And we're just going to do the same on router 4 quickly. So MPLS LDP set enabled, yes. LSR is 9994. And our transport address is also the same. And then we just do an MPLS LDP interface add. Interface equals Ether 1 and Ether 2. All right, so let's just quickly go back to our Eve topology so we can just see what we're doing. So we've got 4 routers. All 4 routers are running OSPF as the IGP now. We've got loopback addresses being sent across or being advertised via OSPF. And we have MPLS running on top of all 4 of the routers. So what we can essentially do now is we are going to change the BGP connectivity so that, yeah, exactly, Stefan. So what we're going to do now is just change the BGP peers. Instead of connecting to like 10.102.1 or .2, it's going to connect to 999.1 or 999.3 or whatnot. So let's just quickly set that up. And this we can do by just going to our BGP quickly and updating the peers. So instead of going to get to R2, instead of using that like link IP, we'll just use 9992. And the same for router 3, we'll use 999.3. All right, let's just fix that up on router 2 quickly. So routing BGP, let's go into our peers. This is going to peer with 999.1. And it's going to peer with 999.4. All right, let's quickly fix the peers up on MikroTik 3 and 4. So routing BGP peer. Just see, I've got, okay, that should be to, let's just print details so we see some names. So 0 is peer or R1 and 1 is R4. Okay, that's easy enough. So all that we're going to do is routing BGP peer set remote address equals 999.1 for peer 0 and 9994 for peer 1. So routing BGP peer print detail. If we look at the detail now, we can see we've updated our remote addresses and our peers are already established except the peer to R1. I'll have a look at that just now. And let's just do the same on router 4 quickly. So routing routing BGP peer print detail. Okay, so this is router 2 and router 3. So routing BGP peer set remote address 999.2 for 0 and 999.3 for 1. Hey clap. Routing BGP peer print detail. Let's just have a look. All right, so this is again a continuation of last week's stream where we've got this topology that I think Emil sent through that he wanted us to try and help fix or figure out. And we were struggling where this router 3 was just kind of not learning the routes correctly. So what we've done so far is we've added some OSPF on top of this network. We've added loopback addresses so that we can use the loopback addresses to connect the BGP peers, because I actually want to use MPLS for this VRF leaking instead of just like straight BGP connections between all of the routers, and we've got route reflectors on between the routers. So I want to see if this potentially helps with the connectivity and if the routes look a bit better afterwards. And if it doesn't, you know, then we didn't waste any time, because this is still a functional core network. It's still pretty normal or average to see this type of setup for a core network for an ISP where you're running OSPF with BGP and MPLS. Let's just quickly get back there. Sorry, I just want to open up the stream chat again. Great. All right. My stuff is hanging in an open send state there, which is never good. But I've got an idea why that's happening. So all that we're going to do is we just want to also maybe update our update source to the LO0 address, because I didn't do that. And we're going to have to do this on all of the routers quickly, which is unfortunate, but you know, we kind of know that we had to do that. All right. So we're connecting now via the LO interfaces. Let's just see, does this all connect? Apparently not yet. Let's just quickly fix it up on the other routers. So routing, BGP peer set, update source, LO0. No, we're not making use of BFD. And hang on, LO0 for 0 and 1. We can use BFD on BGP. I feel like BFD works fine on BGP. It just really, it just makes convergence a lot quicker. But if there are some issues, then I'd also maybe steer clear of it. Routing BGP set update source peer set update source to LO0. And we're gonna do the same for number 1. So let's just see, are our peers connecting now? So routing BGP peer print. Okay, both of them are established, which I'm happy about. All right, cool. So our BGP is actually connecting perfectly now. And what I want to have a look at is just our VPN4 routes. We are learning them correctly still. All right, so what we want to do now is initiate that whole failover scenario again. So essentially what happens is we've got this network on the left-hand side, 10.1.1.0/24. And what needs to happen is, let's say MikroTik 1 fails, it goes off, it breaks, its links goes off. And then MikroTik 2 is supposed to take over, and it's supposed to send its routes to MikroTik 4, and then MikroTik 3 should also still know how to get there. So I quickly just want to do some tests here. Let's just, I used MikroTiks as computers. Even though I could probably just add some Eve Dockers or something, this just felt right because it is kind of like a Linux box. All right, so first things first, on this MikroTik 8 on the far right, which is 10.1.2.10, we want to see if we can ping 10.1.1.10. So let's do a ping 10.1.1.10, and we can. So the VRF and all that glorious stuff is already working. Our routing on our core network is already set up for these two networks to communicate, but we want the failover to work. So what I'm going to do is I'm going to stop MikroTik 1, and then I'm just quickly going to jump back on here. And now this is kind of where we were stuck last time. We were getting our timeouts. Even though MikroTik 2 should be taking over all of the routing, and it should be telling these other two MikroTiks, hey, if you want to get to this network, you can still get there through me. I just want to have a look and make sure on router 3 if its peers are not still active or anything. So let's just connect on Winbox with that, because it's a lot easier to verify this way. So our peers, we still have a peer to R1. So I mean, BFD would have fixed that. So all that I'm going to do is just disable that peer. And then I want to have a look and see, is our stuff still timing out? Yes, it's still timing out, which is unfortunate because that is the issue we're having. I want to have a look at my VPN4 routes, and here is the annoying bit. Okay. So what's happening is we are learning routes for the 10.1.1.0/24 network, but our problem is the gateway that it wants to use is 999.1, and its interface is unknown. So that is going to cause issues because packets are going to be coming from this network on the right hand side. It's going to come into our MikroTik, and now our MikroTik is trying to figure out, hey, how do I get to 10.1.1.0/24? And it's kind of not knowing which interface to push it over, and it wants to get traffic to 9.9.9.1, which is an issue for us. How can we potentially make a workaround? Because there's always a way to fix something, you know. Let's just see here. I just want to understand as well what MikroTik 2 is doing. So let's just go there quickly. All right, so MikroTik 2 is up. It's got its peer established to MikroTik 4. Let's just see, has the VRP kicked in? It should have. So the VRP has kicked in. 10.1.1.1 is the IP address for the VRP. I just want to get onto MikroTik 7 as well and see, can we actually get to our gateways and stuff. So can I ping 10.1.1.1? All right, I can. And this is also what my default gateway is 10.1.1.1, which is this VRP IP, which is MikroTik 2 now. All right, so that isn't doing anything that I wanted to. Let's move router 2 on the left side, move router 3 on the right, and I might bring up router 4 as well, like in the middle, so we can figure out how can we make this work. Because the BGP route is there. I don't have any networks here. Oh, let's try something. In the AS10. No, but we're not doing anything here because effectively we're going to our BGP VRFs, and from here we're redistributing our connected and our other BGP routes. We can try and run a trace route. Sure, let's do that. So let's go to MikroTik 8 again. Oh, hang on. Guys, what are you serious now? I quickly just want to have a look at the routes because it's working here. It took a little bit of time, but it is working. I just want to have a look at router 3's routing table quickly. So if we look at our routing, BGP VPN 4 routes, it has updated. It just took a while. But this was not the case in the last stream. In the last stream, it just was kind of stuck on that. Very interesting. I'm going to bring router 1 back up online, and let's just see what the outcome is. Like, what does it do? Because this is interesting. Because technically router 1 should be taking over on VRRP, but I'm half expecting this stuff to drop again. But it's not, and it's probably still routing everything out over this bottom path. Hang on, I just think I saw something. There's some drops. Alright, so that is the drops, and I'm pretty sure it should be showing router 1. Might just have to refresh. Alright, so it is going out over router 1 now. The interface is unknown, but that I think should just fix itself again. It's possible, Tobias, because in the previous session we didn't have OSPF running. Like this was straight BGP between all of the peers, and we were using route reflectors. I also maybe want to turn off route reflectors. Hang on, my peer, there it's connected. So if I look at my VPN 4 routes, this looks perfect now. This actually looks normal. That's very interesting. I want to shut router 1 off again because I kind of want to time and see what happens. So router 1's off. We get those timeouts instantly. Let's just force the BGP off as well. So go into my peers, shut down this peer to router 1, or disable it. You can re-enable it, but it should just be dead. Yeah. No, that it did clap. It's just in the last stream it didn't learn a route at all. It wouldn't work. So I'm not sure if adding the OSPF or adding the MPLS helped with that. Yeah, that's possible, Tobias. It's just with very, like, let's say small topology like this, where there's almost like 4 routers, there's kind of almost directly connected with each other. But OSPF does also have a few, let's say, a little bit of time to, like, send out the database or update the database. So that is possible. I wonder, I really don't want to use BFD with, no, but we shouldn't have to use BFD with the OSPF. Let's just see, still timing out, but I'm very confident it's gonna start working. I just expected the time to be a lot quicker, that's all. But there must be ways to also make that a lot quicker. Just run the ping again. Okay. Yeah. I feel like it's gonna take like 2 more minutes. Okay, while that's happening in the background, because I don't need to keep this open, is there anything else that we want to tweak in this lab for redundancy? I mean, the BFD is definitely something we can add. Yeah, we can run Sniffer as well. That should be fine. But I'd probably want to run it on router 4. Now there it started working on its own. So let's say it took roughly 2 minutes for convergence to occur. And that's now between these two networks. And we didn't have to initiate a ping from the left network. It's just, it took some time for router 3 to become aware of how to get to that network via its new hop. I think to make this a lot simpler almost is, my recommendation would almost just be to remove the route reflect across all of these routers, bring in an actual route reflector, and just have all the routers connect their BGP peers to the route reflector, and then from the route reflector convergence should be a lot quicker than it's doing this way. Let's test it out actually. Oh man, but that's going to take a little bit of time. And I actually want to see if we can get into that NAT question of yours, Tobias, as well. I don't know. There's no way to be like, hey guys, what do you quickly want to do? But would you guys be interested in me adding a route reflector into this topology? Essentially, we're just going to change where the peers are connecting to, so that it's a lot quicker if stuff needs to reconverge. If one of the routers goes off, it has nothing to do with this whole path or anything. It's the route reflector is figuring everything out, and then we can see if it's a lot faster if we shut down MikroTik 1. All right, so let's quickly do that. Let's bring in a route reflector. So we're just going to add another MikroTik router quickly. MikroTik router OS. We're going to run version 6481. And with route reflector, it shouldn't take that long. No. What we're going to do is call this R5. It could be MikroTik 5, but let's just make it that. I just like adding 12 ports because I'm used to that for some reason. And let's add this puppy here. Wait, let's actually change the name. Let's make that RR for route reflector. And the route reflector should actually be here, but my management network is there right now. Can I maybe do something cool? Oh, I wonder. Hang on, I'm actually just going to delete the connections to MikroTik 3 and 4, because let's just say those are the MikroTiks we work on with command line. And then I'll just bring the management network in this way, so it looks a bit better, and then I can put the route reflector in the middle. So route reflector ether 1 goes to MikroTik 1, ether 2 will go to MikroTik 2. So ether 2, all right, all of them will come onto ether 4, so that's quite easy to remember. All right, ether 4, ether 4. Let's just add another IP address here. So this is called EvenG, Tobias. It's a network emulator. I prefer using this because it works the best for me. But you do have other emulators you can use, like GNS3. Specifically, if you want to get use MikroTik, I'd probably say EvenG and GNS3 is your best bet, because the other vendors, you get stuff like Cisco's Viral, which is very accurate with their images, but then you're just doing Cisco stuff. You get Cisco's Packet Tracer, but again, that's just Cisco stuff, and Packet Tracer is very limited in what you can do. Then you get people, you get many different emulators, but EvenG, I'd say, is probably one of the top ones. All right, we've got a route reflector. And I might just have to do the route reflector configs on the command line quickly. So let's just add that stuff here. Admin blank. No, That's awesome, Tobias. Congratulations. Cisco, are you going to work for Cisco, like the actual company? Because if you are, congratulations. I'm sure that's going to be a ride. I've always loved working on Cisco's equipment. I mean that if you get into networking, like Cisco is the big thing, right? Like everybody's like, Cisco's so big, you need to know Cisco, you need to get your CCNA. Everybody uses Cisco, and it's true. It is really true. It is a very valuable certification to have, and it's awesome. I love Cisco. I love iOS. That's why you see me like on the command line a lot as well. It's just a habit from working on Cisco and Juniper routers. But what people also need to understand with MikroTik, you can do everything on the command line. Like there might even be things that you can do a bit better from the command line as opposed to being on Winbox. Even I don't have issues. Like Winbox is a very nice graphical user interface. I actually respect, or I think it's amazing that MikroTik has Winbox, because it does make it a lot more user friendly. But it also, I don't want to say it breeds laziness, but I don't know. There's stuff I love using Winbox for, and there's stuff that I use the command line for. Like troubleshooting or configuring stuff, I'll probably use command line, and then if it's like uploading backups and stuff, I'll use Winbox. Oh, where was I? We've got a system identity set name RR. Nice. Okay, so we've got a route reflector. So all that we're going to do now is just add a bridge interface as well. So interface bridge, add name LO0. Let's add an IP address of 999.5 to our bridge. And what we're going to do is we are going to set up OSPF for this as well. So I actually need to have a couple of networks connected to the route reflector now. What can I make? Something simple and easy. 10. Let's just make it 10.0.0.0 dot whatever. So router 1 is 10.0.0.0. Router 2 is 10.1. Just want to make sure it doesn't interfere with any of the other IP address. But it shouldn't. To router 3, it will be dot. Hang on, let's simplify it. Let's make that dot 2. It makes it a lot easier to remember as well. So 10.4.0.0/24. The route reflector will be .1 on all of the all of its interfaces, and the other routers will be .2. Thanks for watching, man. Appreciate it. Have a good evening. All right, so let's quickly add our IPs to our interfaces on the route reflector. So IP address add address equals 10.1.0.1/30 on ether 1. Ether 2 will be 10.2. Ether 3 will be 10.3. See how easy that is? Ether 4 is 10.4. Alright, very nice. Let's just quickly add our OSPF stuff as well. All of the other stuff we'll just quickly add it, so we don't have to come back here. Well, we will have to, but you'll see. So routing OSPF. Routing OSPF instance set name. We can make this backbone. Oh, let's just set the router ID as 9995. We didn't set the router IDs on the other ones, but it's fine. It would have automatically just been assigned, and it shouldn't have interfered with anything. So let's just do routing OSPF network add network 10.1.0.0/30 in our backbone. .2, .3, and .4. And let's quickly just update those interfaces. So routing OSPF interface add interface equals ether 1. and our network type is point to multi-point. So we'll do that for 1, 2, 3, and 4. Okay, so we've got our network. Our OSPF, I think, is actually done. Let's quickly just add our BGP peers. So routing. BGP peer add name peer to R1. Let's just do the remote address equals 9991. Remote AS equals, I quickly need to fix something. Hang on. We need to just add that instance. I don't have the instance here, so routing BGP instance, add name AS10, AS is 10, and our router ID will be 9995. Okay, this will be in the main routing table. Now let's do a routing BGP peer add peer name peer to R1. I don't know why I made it RE. Maybe I've been playing too much Resident Evil. It's actually a really fun game. Peer to R1. Remote AS is 10. Remote address is 9991. For this, we're going to allow route reflect. So instance is basically where you can set what your autonomous system number is on the router. And it is also going to be where you can set which route you want to redistribute. I'll actually show you a little bit more in detail just now. Let me just add these peers. Actually, let me show you before I just continue. Also, I might lose my train of thought. So if we go into a routing BGP, you'll notice there are instances. By default, this instance is just here. MikroTik just adds this, but this is like, I think this is a private AS. It might be theirs, but it's probably private. But here we can add as many instances as we want. But this instance that you add, you can make this whatever you want. So this could be, the name could be ISP, my ISP, or whatever. And let's say you are an ISP and you've applied for an ASN from your registration numbers people, like, you know, the people that give you IP addresses and autonomous system numbers. And they've told you, hey there, mister, your autonomous system number will be 65518. That is your autonomous system number when you connect to the internet. That is the ASN that you will give your BGP peers if you want to share your public routes with them, or if you want to just peer with them so that you can learn their routes and interconnect through their networks. I mean, this you might see happen with other ISPs. So between ISPs, this is quite common to do. But you might also see it with services like Amazon or AWS, Netflix even. People might peer with Netflix, learn Netflix IP ranges. And if you want to peer with Netflix, you're going to need your own AS number to peer with them. So here you'd have your own AS number and your router ID. People probably just tend to use their like one of their public IPs for this, but the router ID has to be unique for each router. Which is why in my topology, each one of them should have something like 999.5 or 4 or 3 or 1 or whatever. Not completely. BGP does have a form of authentication, but what BGP does is it allows us to learn routes dynamically over the internet, over internet exchanges. Because what you would do is, hang on, let me just quickly close this. I'll bring up the lab again, guys. It's not dead. All the stuff is still up and running. I just want to go into our bigger topology quickly. So this was the topology that we started the streams with. But this will be a little bit better to explain what I'm trying to explain with internet exchanges. So basically, let me just zoom out here. What would happen is I would be an ISP, I'm ISP1, and I have a ASBR or a router that's actually connecting to an internet exchange point, an IXP. Or it could be connecting to another ISP, and I could be using that ISP as a transit network, and they are actually connecting to the IXP. But what happens is you would peer with the IXP, or you would peer with another ISP, and you would basically tell the other ISPs or tell the internet, what are your public IP addresses? What are my IP ranges? And here is my IP ranges, and to get to any of my public IPs, this is the path that you're going to follow, because BGP is a path vector protocol. It makes use of it adds a path on each I don't want to say packet, but on the routes to see how it got there. So if you have a look at a BGP route, you can see exactly the path it took to get to your equipment, because each ASN would have its own AS, or each ISP would have their own AS number. So let's say there was a third ISP down here, and if they wanted to get to my ISP1 subnet and they were connected to ISP2, then it would show them to get to my subnet, you're going to go to AS65200, then you're going to maybe go to AS65100, and then you'll finally get to AS65000. Really cool stuff, actually. And that's how the internet operates. BGP is so massive, and it's really awesome to see. And that's why it's exciting to see what MikroTik's doing with BGP in version 7, because version 6 BGP has a little bit of drawbacks. A lot of people complain, hey, it's only running on one CPU core, which is pretty bad. But it's not the end of the world. I mean, it still works, but it is a limitation, and version 7 takes away that one CPU core limitation. And besides that, the BGP just works a lot better. I did do a stream on BGP on version 7 a little bit ago. All right, anyways, back on point. Let's fix up our, I don't want to say redundancy, but let's fix up our routers here. All right, so I've been adding my BGP peers now. So I've added a route reflect. So what we're going to do is we're just going to peer with the route reflector, and the route reflector will reflect the routes to us, and things should be a little bit better. So let's see here, routing BGP peer, add. We've got our name, we've got our AS. I need to set my instance as the AS10. Let's just see, am I missing anything here? Let's just set an update source. So the update source will be LO0. No worries, Tobias. I'm happy if you ask questions and engage with me, That's what the stream is for. It's not just for me to, I'm not going to say I'm a teacher. I'm learning with you guys. I'm also a network engineer, and I'm also figuring everything out. I've worked with ISP networks for a while, so I know a few things, but I'm not going to be like, I'm the best pro guy, you need to do what I tell you to do. I find it annoying sometimes if I meet people like that, because I know what the struggle is like. We're all learning all the time, and there's stuff that you forget and you need to relearn it. And I mean, that's kind of part of the job, isn't it? And that's what keeps it exciting. But there's also always something new coming out, which can make it hard as well, but it's also good. So we've got our update source, name, remote AS. This looks okay to me. Let's just, no. Let's just, what did I do? I didn't add it now. Let's just copy that. And, no. Hey, Nicola. So, Nicola, it seems like the, let's say the OSPF and MPLS did help with this setup, but we're having an issue where the convergence takes really long. So what I'm going to do is try and bring in a route reflector into the topology and see if this maybe helps with reducing that convergence time. All right, I just want to, I just open up a normal notepad maybe. I don't know why my computer is being weird with this now. Okay, let me just type it in from scratch again. It's fine. It's not the end of the world. So what we're going to do is routing BGP peer add name. Peer to R1, remote AS equals 10, remote address equals 999.1. Route reflect equals yes, instance AS10, update source allo. Oh, I know what I was missing. So let's add a address family. So there should be IP and VPN 4. All right. Routing BGP peer print detail. All right, that looks good. I'm just adding peers quickly to all of the other routers quickly. So let's add to router 2. Router 3 and router 4. That's also true, Nicola. I just want to check if the reconvergence is a lot quicker, because what we can do then is rather look at adding redundancy to the route reflector, because we could add a secondary route reflector and just have that like fail over if the one route reflector dies. But we'll see, because the solution kind of works right now like this, but it's very slow for reconvergence, and that's not ideal, because the you know our clients are, if it's not working in 5 seconds, like 5 seconds is too long, and it's taking about 2 minutes to learn the routes. All right, let's just see here. I've added my route reflectors. I've added my peers. So now I just need to form peers to the route reflector quickly. All right. Let's do this. Let's peer. Why is my peer to R4 not working? Just disable, re-enable. Because that's R2. Come now, R2, why are you not connecting? All right, let's maybe try and bring in R1. That looks like R1. All right. So I've somehow lost connectivity with the right-hand side network. Interesting. That's true, Tobias. That's very true. Let's just see here. I just want to see why my peers to R3 and 4 have stopped. I can kind of see. I think you may be right, Nicola, but I'd like to play around with this, if that makes sense. And then we can also test confederation. I've always wanted to make a video on BGP confederation, like, but then I'm scared that people will like take offense, because I want to like play that I don't know, that Yankee Doodle song like the Americans play in the background. But I know a lot of people, I don't know, they get upset for strange things, and I don't want to upset people. Why are you not working now? I'm just going to disable the route reflect on the edge routers quickly, because I don't want them to route reflect. Okay, wait, that was router 1. Let's quickly go to router 2. Oh, that's nice. My brother is actually in Australia. He's in New South Wales. So that's pretty cool. I know the time difference because sometimes he'd also message me or send something, and it's like either it's very late here and then it's super early there or whatnot. I want to get onto router 3 and 4 quickly. So routing BGP peer set route reflect no for 0 and 1. Do you also have it's also 9 p.m. here, Tobias. Exactly. So we're on the same time zone, but it always shifts a bit whenever that whole DST thing happens, because in the south, because I'm from South Africa, we don't like shift our clocks or anything. So I don't want to say it's annoying, but I also play, let's say, online games. I play a game called World of Warcraft, and I kind of run a guild on there as well. And then every time it becomes like an hour later for me. And so then I need to do things later in the evening. So right now it's very nice. Later on it's not that nice. All right, let's just quickly do a routing BGP. I just want to do the same on router 4 quickly. Wait, I didn't do that yet. So let's just do that. Peer print. It's actually a little bit annoying that my peers are down. Why do I have BFD enabled there? Oh, I think I wanted to show you guys something with the BFD, didn't I? But I don't have BFD enabled there. Let's just see, am I learning the routes? IP routes. I'm not learning the OSPF routes anymore. And that's why I can't form a relationship. So let's just quickly, I know it sounds weird, but let's just quickly restart those routers as well. Because this only started happening after I added the route reflector, and it should really have no impact. All right, while they're booting up, let's just finish that type of setup where I just quickly want to add IP addresses for the route reflector. So that's Ether 4 on all of the equipment. And this was going to be 10.102/30. And let's just add that to the network. 10.100/30. Okay, and we want to do this on router. Wait, did I do that on router 2 now? That's incorrect then. Let's quickly fix up router 2. IP address. This should be .2. Okay, now we're good. Let's quickly go into router 1. Add this address here. So on router 1, 10.102/30 on Ether 4. And we're just going to add that to our network. Sure thing, Nicola. We can definitely have a look at that. I'm always going to be streaming on Tuesday, so I feel like there will be ample time and we will get to it. 10.100/30 is my router 3 and 4 back yet? Let's see. Admin blank routing OSPF. Let's just see if our OSPF neighbor is connected. I do see to both routers. Okay, this looks good. I wonder what happened. That's really weird. Let's just see on router 2. Am I learning those routes? Yes. All right. So I actually think the BGP is working now. Okay, cool. All right. They just needed a reboot for whatever reason. Did I finish router 1? Yes, I did. Okay. Let's just quickly set up router 3 and 4. So IP address address 10.3.02/30 on Ether 4, routing OSPF network add network 10.3.0.0/30 in our backbone. And this feels like, this is what I prefer CLI. This felt a lot quicker than clicking menus and stuff in Winbox. I don't know if everybody agrees, but that's how it feels to me. Admin blank. So IP address add address 10.4.0.2/30 on Ether 4. And then routing OSPF network add network is 10.4.0.0/30 in the backbone. All right. But now we also need to connect to that router via our BGP. And I probably have to just disable the other BGP peers. So on router 1, let's just start there. On router 1, let's go into our BGP peers. Going to just disable these two for now. I'm going to add a new peer, peer to RR, we can call it that. It will be also an AS10. Our AS was 10. I won't set any of these other details, but I will go into my advanced, enable the VPN 4, and set our loopback address for the update source. Let's just see, is this connecting? Oh wait, I didn't add my remote address, 9995. Right, I should get an established peer now. Just maybe disable, re-enable. Oh wait, did I add 9995 in the OSPF? Let's just see. Routing OSPF network export. No, I didn't. Routing OSPF network add network 9995. Area backbone. All right. And I should see that the peer should be able to connect as long as I'm learning that OSPF route. Let's just see, can I ping it yet? Ping 9995. No route to host. Is my OSPF actually forming an adjacency? Let's just see, neighbors. I do have a neighbor. Is my interface set? It is, but it's not point to multi-point. So let's just quickly set that. And let's see, am I learning that route now? I half expect us, there we go, 9995. There we go. Okay, let's see our peer now. There we go, peer is established. And I am learning the VPN 4 routes through that. No, wait, these are my local routes. Right. But let's just quickly add more of the other setup, like the other routers. Else this isn't going to work very nicely anyways. So let's add a new peer. This will be peer to RR. Instance AS10. 9995 is our instance. AS is 10. Not setting anything else here. VPN 4 with LO0 being our update source. Let's just apply that. And I might just, okay, I'm already connecting, so that's perfect. see here. That looks interesting. All right, next bit. So let's go into our other routers. We'll quickly do them via the command line. So router 3 and 4, so it's these two I can just use from here. So we can go routing BGP peer, disable 1 and 0, routing BGP peer, add name peer to RR, remote address is 9995, remote AS is 10, our instance is AS10, our update source is LO0, our address families is IP and VPN4. Am I missing anything? Doesn't look that way. Hang on, our update source is not correct characters. There we go. So if I look at my routing BGP peers, I can see I formed a established connection with the route reflector. And let's do the same on router 4. So routing BGP peer, disable. Let's disable 0 and 1, and let's do routing BGP peer, add name peer to RR. Remote address is 999.5, remote AS is 10, address families is IP and VPN 4. Our I didn't set the instance yet. That's AS10, and our update source is LO0. So routing BGP peer print, all right, that is established. So that's on router 4. Routing BGP IPv4 routing BGP VPN4 routes. Let's just see if I print this, what am I learning? I am learning the routes, which is brilliant. Let's just look at, there we go. So I'm learning the routes that I'm expecting to learn. All right, great. This is actually what I wanted to do. So now on our topology, we have a route reflector in the middle. That is basically where all of the provider routers is establishing their BGP peers to. And this route reflector is letting them know where everything is. So what I want to test is if MikroTik 1 goes down, how long does it take for the route reflector to actually update everything? I will actually just quickly add BFD so that the process is going to be a bit quicker, so I don't have to just go and disable like the BGP peer on the route reflector. Yes. So VRRP. So Tobias, for you, because you weren't here with the last stream, basically MikroTik 3 and MikroTik 4, which is these two, as well as MikroTik 1 and 2, they are running VRRP, where they've got a IP that's floating between the two of them that this network uses as a default gateway, so that in the event that one of the MikroTiks die or go down, the other MikroTik can just take over as the gateway, and then traffic should flow normally. And that was kind of like where we're having issues with the routing as well. So this 10.1.1.1 IP that MikroTik 7 uses as a default gateway is the floating IP between these MikroTiks. So then technically what needs to happen is the IP is live on MikroTik 1, and then if that MikroTik goes offline, the MikroTik 2 takes that IP and becomes the active gateway, and then traffic should just keep working. Okay, but I just want to enable the BFD quickly, but this is literally just going to be a tick. We're not going to tweak any of the BFD settings. We'll leave it as default. I just want the convergence to be a lot quicker, and that's why I want to use BFD. So MikroTik 3 routing BGP peer set, use BFD yes on 2, and that should be the same on router 4. And let's just quickly do the route reflector. So routing BGP peer print, routing BGP peer set, use BFD yes for 0, 1, 2, 3. All right, so now we are going to use BFD just for the conversions to be a bit quicker. And if I look at my peer, it is established. Okay, so I'm fairly happy with this. So let's do the test again. So what we're going to do is we're going to connect to MikroTik 8. I just want to see if it isn't open already. It is. All right, so MikroTik 8, it's currently able to ping 10, 1, 1, 10, which is the host on the other end, which is one of, let's say it's a server, it's a computer, it's a user, it's something. So what we're going to do is we're just going to shut down router 1, which is where the VRRP runs. Stop that. And I want to see how long the reconvergence takes now. Because remember, previously it took about 2 minutes. I want to cut this down a bit. But while that's happening, I just want to connect on to router 2. I don't want to minimize that exactly. But router 2 should have already taken over the VRRP IP. Let's just see. It has. So 10, 1, 1, 1. It's live on router 2. Okay. Let's just see on router 3, routing BGP. Still timing out. Let's just try and make it like that so we can still see if it's timing out. Routing BGP IP, let's see, VPN 4 route print. So router 3 is still learning the routes, but it's still trying to get to 9991, which was our initial issue. Sure, you can share your theory, Tobias. Because I just want to have a look at the route reflector, routing BGP peer, routing BGP VPN4 print. So it is learning these routes, but it's still thinking if I want to get to 10.1.1.0, then I need to go here. BGP peer print. Oh, okay, that's quite interesting. So our issue is that the peer is still alive or established for this router. All right, I've got a suspicion. Let's just quickly disable the peer. I can't see how though. We've terminated that router, and now none of my peers are established. That's not good. Thomas, so we could use BFD on the OSPF neighbors just to help with that reconvergence, but I have seen articles as well that says BFD is a bit iffy when it comes to larger networks and you're running OSPF, that it can cause issues with the network kind of like flapping almost. So I'm kind of scared to put BFD on the network since I've seen that. I've seen it happen as well. Like I know it's a thing that can happen, even though it shouldn't. But like there's articles that just says don't worry, it will be fixed in version 7, and that's not a good enough answer for me. I'd also like it to be like perfect now, but I'm personally scared to use BFD on OSPF, because I've seen it like be weird. It hasn't happened on BGP for me, but yeah. But we can add it on, this network is pretty small. I just don't like that this route reflector isn't learning any routes now. So my OSPF almost like died. Routing OSPF print. Routing OSPF not instance, neighbor. Let's just see. So I've got 3 neighbors. I've got the 3 neighbors, so technically I should be learning routes. But I'm not. Alright, let's just do something. And I'm going to stop all of the routers quickly. Stop them all. And then we're going to bring up all of the routers except router 1. But the thing that I saw that was definitely an issue just now, Tobias, was on the route reflector, it still saw its peer up as for MikroTik 1. And that would definitely cause issues, because it would still try and like tell people, hey, if you want to get to that network, then that's how you get there. All right, let's just start up again, but not router 1. I want to start up everything except router 1. I just want to have the OSPF work, and I want to make sure the route reflector is connecting to MikroTik 2, 3, and 4. Yeah. You know what's funny with the speeds on these trial MikroTiks that I'm using? They are all capped at 1 meg, which is so slow if you think about it. Like back in the day, that was the speed, right? But right now you can cap out 1 meg very easily, just winboxing to a device. Like Winbox doesn't do that, but Winbox uses like 130 kilobits. So imagine you had a bunch of Winbox sessions. I don't know. All right, the router should be back up. Let's just go into our route reflector quickly. Admin blank IP route print, IP route print. I just want to make sure the OSPF is actually connecting, because if that doesn't connect, we are not connecting to anything. Neighbor print. All right, I can see my neighbors, but I'm still not learning any routes actually, which is a problem, a big problem. Admin blank IP route print. So you are still learning routes, but you guys are having issues connecting to router 5 or route reflector. Routing OSPF neighbors print. You can definitely see. Little bit annoying because the adjacency looks good. It looks how I expect it to be. Route print, routing OSPF. The settings are fine. Backbone, router ID, that's fine. Yeah, these are all good. What I might do is just quickly add this to my management network. Don't worry, this doesn't belong there. And let's just winbox in. So this might be one of these times where I need to winbox in to check a few things. Yeah, sure, Tobias. Thanks for watching. Sorry I didn't get to your NAT question, but I would like to also put that in a lab and let's figure it out together, you know. But thanks for watching. Have a good evening, man. All right. I'm just going to sort out this one thing, and then I'm also actually going to head off. Let's see here. Routing, OSPF. These are all fine. It's running. Yeah, this is all good. But I'm not learning a single route. Let's just turn MikroTik 1 back on. Hey, Vinoth. It's going to be so weird if I turn on MikroTik 1 and then the OSPF starts working again, because that doesn't make a single lick of sense. Because I can see the neighbors are connected. I can see the adjacency, but I'm not learning any route. No, come on. But what I do realize is that all of my routes are saying to get there, they need to go out via Ether 1. So it's like I'm learning all my OSPF routes via Ether 1 for a very weird reason. It should not be the case. Routing OSPF networks 10.1.0.0. Let's just compare it with router 2 quickly. That's router 2. I'm pretty sure I did add the networks on the other routers, but maybe I forgot, who knows. Let's look at our OSPF network. 10.2.0.0. Yeah, it's on both ends. Oh, that's why. That's definitely going to cause an issue. Point to multi-point on Ether 4. Okay. Let's quickly check out router 3. Routing OSPF interface. Yeah, I didn't set the interfaces to point to multi-point, so this is definitely why that route reflector was actually reliant on router 1. So let's just quickly add this routing OSPF interface. Add interface Ether 4, and its network type will be point to multi-point. And we'll do the same on router 4 quickly. Admin blank. Alright. So if I go onto the route reflector now, we'll see that the routes have updated correctly. So everything's not Ether 1 now. It knows about Ether 2, Ether 3, Ether 4, all those places. Okay, now we can try and do that other test again. So all that I'm going to do is go onto router 8. We run the ping. Okay, but the ping's already running, but it should be going over MikroTik 1. So let's quickly kill MikroTik 1. We'll stop you, and then we should be getting some timeouts. So while those timeouts happen, I just want to see my BGP here. All right, so the peer to R1 is still here. It's still up, even if we're using the BFD. Let's just force this off quickly. All right, so reconvergence time is definitely going to take long. Even though we're using the route reflector now, and we are connecting, well, even we've even disabled the peer on the route reflector so that it should in theory update the routes. But our issue is on router 3. If I do a routing BGP VPN full route and I print this, it's going to see to get to 10.1.0.0, the gateway is going to be 999.2. But it's the interface that is going to be interesting. I just want to see, can I expand that? Let's see, can we do detail? All right, we can. And our issue is the interface ether 4. All right, but that's actually fine. Because now it's just pushing over the route reflector to get to MikroTik 2. Man, we still haven't gotten this 100% right. I mean, it is technically working. It just takes like 3 minutes for the reconversions to kick in, and then we can get to the other side. I just want to wait for this to actually come up and make sure it is working, and then I'll probably end off the stream. So let's just give it a minute while we're waiting. I mean, if some people have some more questions, feel free to ask. I mean, if I can't answer, I will. If I can't, I'll tell you as well. Hey, I can't answer it. We can try and figure it out, or we can Google it, or, you know, look at what's going on. Okay. Okie dokie. Give it another minute while that's happening so people don't get too bored. Let's just see what's happening on router 2. Let's just bring this to the side so we can actually see when our pings do start responding, if they even start responding. All right, so Thomas, so for me, we can use the BFD. I see you. Okay, so we can use BFD. I'll put the BFD on actually on the OSPF network as well, just so that everybody can see what it does, because this is a very small network, so BFD shouldn't be an issue. But BFD can cause potentially issues. I'm not going to say it is an issue, but it can potentially cause issues with big OSPF networks. All right, but then my ping started working. I don't know if it's coincidental that I started adding BFD there or not, but now we can actually get across between the two networks. I mean, this is actually fine for redundancy as long as the customer understands, hey, it's going to take like 3 minutes to automatically fail over in the event of one of the gears, one of the MikroTiks dying on you. So technically this is, let's say this is point-to-point because this is a direct connection between these two MikroTiks, but how the connection works doesn't really like change if you use point-to-point or point-to-multipoint. I actually argue more or less that this is point-to-multipoint because I do have my 3 different, like this almost looks like a hub and spoke if you think about it. I've got a route reflector in the middle. All of these devices connect to the route reflector. I could actually take out these links between these routers, but I'll leave them connected just for the OSPF sake, and it'll work fine. Like it's actually pretty standard to just see it on point to multipoint. My personal preference is just to leave it on broadcast. The default, like when you set it up and you add a network and it adds the interface automatically, it's on broadcast. And like why I enjoy broadcast, or why I like broadcast, is if your network is set up in this way, then it will automatically add stuff like a DR and a BDR router, so that your routers do, like, let's say, less work with the database. The database can just be picked up from the DR instead of all of the routers having to do the database, you know. All right. I've kind of lost my train of thought. Last thing we were doing was just adding BFD to the routers quickly. So let's just do that very quickly. So let's say routing OSPF interface print routing OSPF interface set use BFD. Yes, we can use that for 0, 1, and 2. 0, 1, 2. And we're going to do the same on router 4. 2. Is router 1 still dead? It is. Let's just start it up so we can put on the BFD, and let's just add it onto the RR as well. So routing OSPF interface print. Routing OSPF interface set use BFD yes for 0, 1, 2, 3. And let's connect on to MikroTik 1 again. It is this one. And I'll just quickly add the BFD on my interfaces. Use BFD. Use BFD. Use BFD. All right, so the BFD is being used for the OSPF as well. So let's do the same test, but I'm not going to wait like the whole time to see if it reconverges. Ooh, it's actually dead at the moment. Let's just make sure that all our stuff is up. Routing BGP. Our BGP is idle at the moment. Alright, all that I'm going to do is quickly restart and start up all the routers again. Stop and start. Okay, that's router 2. That's router 1. All right, let's start up. All right, our nodes are back up and running. And I'll just quickly check at router 8. Can I ping across yet? No, not yet. Let's just check on the route reflector. Is the OSPF actually connecting? Because if it's not, then that's an issue. Routing OSPF neighbor print. All right, I've got neighborships to all of the routers. I am learning routes. Can I ping .1? No. Can I ping .2? No. .3? No. So the OSPF portion is working. Let's just see if the BGP is connecting, because the service is being done via BGP. So if the BGP is not up, it's not going to work either. And so our BGP is just idle at the moment. Let's ping 9995. It's going into an open send state, and this only occurred after we added the BFD on the OSPF network. I'm not sure if this is causing some type of issue with the BGP. Let's just do a test. I'm just going to remove BFD on router 2 and or router 1 and the route reflector. So let's just see. And I should just be able to disable it on that interface. So let's see, route reflector, routing BGP, not BGP, routing OSPF, interface print, routing OSPF, interface set, use BFD null for ether 1. Let's actually just disable it on all the interfaces on the route reflector. And then I want to just disable, re-enable my BGP peer or session. Has my OSPF actually updated? Yes. So this all looks fine. But if our BGP is not working, we're never gonna like deliver the VRF service. Why are you going into an open send state? Come on. That's uncool. Okay, I'm just going to completely remove the BFD quickly. It shouldn't take too long though. Alright, but this is connected. Hang on. No money. Routing OSPF. Disable this stuff. Alright. And let's just quickly jump onto the other MikroTiks. So MikroTik 3. Admin blank, routing OSPF interface print, routing OSPF interface set use BFD no for 0, 1, 2. Admin blank 2. Okay. I'm pretty sure this was connecting. Okay, let's go back to router 1. But let's just see, can router 8 actually ping across now that our BGP is back up? Ping.10. No, that can't ping either. So we've really broken something somewhere along the line where we've added the BFD. Oh, I think I'm being simple. If I recall correctly, I actually disabled the peer to router 1 on on the route reflector. Yes. Okay. So that's why that's not connecting, which is actually kind of expected, isn't it? And let's see, can MikroTik 8 ping across now? It can, but it's having a weird issue. That doesn't look healthy at all. One packet drop and one packet doesn't drop. All right. Let's just quickly force reconvergence by doing one more restart of the network, but everything is how I expect it to be. So I think everything should work fine after this restart. We just want to have all of the routes or routes come up properly now after we restart. All right. Now I just need to wait for all the BGP peers and stuff to come up. Oh, boomtick. I wouldn't say it's bug tick. Maybe sometimes, definitely. But what I do find is, and it's not just with MikroTik, all of the vendors, if I use emulation software, like I don't want to say it's EVNG, but even on GNS3, I'd sometimes run into issues like this where you might have to like take out the cable in the topology and plug it back in for the stuff to work. All right, let's just jump back onto router 1. That should be router 1. My peer isn't established yet. Am I learning my routes via the OSPF yet? I am. So there we go. There's my peer. So if I've got a peer, I should start learning VPN for routes. Okay, that's good. So I kind of expect this to work now. There we go. So everything's working correctly and we don't have that weird I actually think you're right, Nicola. I think it was probably something with the VRRP, why we were seeing that one, like a packet dropping and a packet not dropping, if it makes sense. All right, but right now the ping is fine. The VRF is spanning through correctly. This is good. This is what we want. I'm just quickly going to do the test again where I'm turning off router 1 so that the VRP can take over. So let's just stop that. And what I might do is just delete that cable as well, going to the router reflector, because that might force the BGP peer down as well. And let's just jump onto router 2 and see if it takes over. That's router 2, because that's how I know it's router 2. Okay, so on router 2, my VRP is the master now. And the IP10.111 is live on router 2, which was live on router 1 first. And let's just see, can I ping 10.1.1.10? That's not true. I should be able to ping 10.1.1.10 IP route print. Oh, obviously IP, let's just ping 10.1.1.10 from VRF 1000. There we go. From the source IP of 10.1.1.1. Alright, so it's just a reconvergence that it's pretty bad at the moment. But the solution in theory works. It just takes us 3 minutes to actually get everything up and running. So I might actually look at the configuration in the next stream. And also, like Nicola, keep your questions coming. I actually love seeing your questions, because you ask a lot of good questions as well, and things that I can think about maybe making like a video or doing in the stream. But yeah, guys, I actually think this is where I am going to call it an evening. I think we've learned a bit more, especially when it comes to the route reflector and all that stuff. But I hope you've learned something at least. And if you didn't, let me know what type of stuff you want to potentially see me try and figure out on MikroTik. It doesn't necessarily have to mean I'm your teacher. It can be something that we figure out together. So thanks for watching. I hope you guys have a great evening, and I will catch you guys in the next stream. Hopefully I'll start uploading some actual tutorial videos again, but I'm really struggling with time right now, especially with the baby in the mix. If you guys are fathers, I'm sure you can relate. It's wonderful. I love spending time with my baby, and that's actually the thing. I prefer spending time with the baby than making new content, which is also kind of a drawback, because I want to become more self-reliant so that I can support better for the baby. But you know, it is how it is. All right, there we go. Our link's back up, and I'm calling it an evening. Catch you guys again. Thanks for watching again. See ya.